Good morning. So this is the first of two brief sessions that I'm going to do for you guys, just to review the unit on relations and functions in preparation for your test. So the first one, well, maybe before I say that, there are kind of three broad chunks to this chapter. One of them is interpreting graphs. So look at a graph, decide what's going on. Is it a linear relation? And then further on, is it a function? The second big chunk is that whole chunk around domain and range, right? So what is domain and range? How do you express domain and range using set notation primarily, interval notation as well, and thirdly, the whole function notation. So how do you convert something from an equation into variables into function notation, and then how do you use function notation if given the value of one variable, the x or the y, how do you find the other variable? Okay, so those are kind of the three big chunks. We're going to look at the kind of graphing and interpreting graphs and a little bit of domain and range today. Okay, so at the very beginning, we just looked at interpreting graphs. So for instance, this one says, describe a possible situation. Well, in order to do that, look at the title. Look at the vertical axis label, look at the horizontal axis label. Remember, if you have time as one of your variables, it's always on the independent or horizontal axis. Always, always, always. Okay? I've marked a couple of your assignments so far, and some of you made that mistake. But anyways, take a look at the graph, title, labels, and come up with a situation. So we have distance from home, we have time in minutes. It's called Troy's hike, so he's probably hiking. So to describe a possible situation, you could say Troy starts out at home because it's at zero distance from home. He hikes to the park. He hikes partway back and stops at the store. He gets something to eat and sits in front of the store and eats his tasty candy bar. And then he returns home. Okay? There's a million different correct answers for this. So long as your description fits the graph, you're good. Okay? Here's another one. And again, just asking for a possible description of the trip home. Okay? So this time you have speed and time. He speeds up. He stops for a while he speeds up and he maintains a constant speed, right? Maybe it's 100 kilometers an hour. He sees a light ahead of him, so he slows down to a speed of 0 at the red light. Light turns green. He speeds up again until he gets to some constant speed at the end. Okay? And again, that's just one possibility. Sometimes you're given a set of ordered pairs and you're asked to graph it. So this says, convert to a set of ordered pairs. Well, that's easy. Remember, an ordered pair always consists of an x coordinate, which always is written first, and a y coordinate, which is written second. Once you have an ordered pair, you can plot it on this grid, remembering that x is your left and right from the origin, y is your up and down from the origin. So this point would be 4 across and 2 down. That point would be right there at 4 and -2. Okay? And you can continue to plot these points. I'm not going to do all of them, but you would plot them all, and if you have a continuous relation, right, 2 measurements or something like that, then you can join the points. If you have a discrete relation, for instance, you're graphing the number of objects, or you're graphing a number of coins, or a number of tickets, or whatever. Things that can't be divided up into smaller bits, that's a discrete relation. Okay? So this next one asks you to convert from a current representation into a table of values. So again, the opposite of the last one we just did. And very quickly, we can pick any of these and convert it into a table of values. So you've got x values and y values. For our first point, from the I guess this is our first point here. It's right at the origin. So that means it would have an x-coordinate of 0 and a y-coordinate of 0. For this next one, it's 1 to the right, or positive 1 for my x. And since these go up by 2's, it's also 1 up. Okay? The next one is 2 across and 4 up, and so on. Okay? Any questions? I did it again. Well, if you have questions, I'm sorry, I can't hear them. Okay, again, they might give you a set of ordered pairs, and to transfer that into a table of values, nothing could be easier, right? For this one, all you need to remember is the first number is your x, the second number is your y. So 0, 0, the next one would be 1, 3, and so on. Okay? The next question is just getting at whether you can identify a linear relation or not. Now, if it's a graph, pretty easy. If it's a straight line, it is a linear. If it's a non-straight line, it's not linear. So this one is, nope, not linear, because you can see this line has a curve. It's a little trickier if you have a table of values. You have to look at each variable and see, does it go up from one number to the next in a regular fashion, okay? So in other words, each time here you're adding 1 to go from one value to the next. If you look over here, you're adding 0 here, you're adding 1, and then you're adding 1, and then you're adding 2. So this one's all over the place, therefore, again, nope. Okay? And you can do the same thing with these. Okay? If you have a regular increase or decrease, it's linear. If you have a straight line, it's linear. If we look at B, you can see right here, you have a degree 2 relation, and remember, linear relations have to be degree 1. So, of the ones we've looked at, none of them is linear. Dependent and independent variable. Again, remember, the independent variable is always going to be your x. The dependent is always going to be your y. So if you're given something like a table of values or an equation, remember y is always the isolated variable, or a graph. In each case, y is dependent, x independent. Okay? So, since this is your isolated variable, and since the volume depends on the radius, right? As the radius gets bigger, so does the volume. For A, our independent is R, our dependent is V. For B, you're given a table of values. X is always on the left, so the independent would be age, and the dependent would be height. In general, the older you get, the taller you get, up to a certain point. Okay. For C, well, they've given us these variables. Remember, the isolated variable is the y. That's your dependent. The x, your independent. And finally, if it's a graph, x is always your horizontal axis, so time, and height is your y-axis or dependent variable. Discrete and continuous. Again, remember, if it's a measurement, we generally say it's continuous. If it's an object as opposed to a measurement, usually discrete. Okay? So here we have temperature and time. Both are measurable values. That's continuous. Here we have cost, which, you could argue that you can't split cost up completely, but cost is something that you can express in a number of dollars and cents. So it is, generally cost is taken to be continuous. However, number of chocolate bars, those are definitely objects, and you can't go into the store and say, could I have a third of a chocolate bar, please? Okay, so that's discrete. Height and time are both measurable, so that's continuous. Okay. Domain and range. Domain and range is where some of you really got into the weeds, okay? You really had difficulty with that. You need to be able to express domain and range, both using set notation and using interval notation, okay? So, with something like this, you can't use set or interval notation when you're dealing with objects. So for these ones, you would basically just be listing, okay? As to whether or not it's a function, if you check your x's, and if you see x being repeated, in other words, this x value belongs both to the pentagon and to the triangle, so it's being repeated, right? You'd have two ordered pairs, 8 pentagon and 8 triangle. As soon as you see an x value repeated, it's not a function, okay? So again, for C, you can see that you have a repetition of x values here, so not a function, okay? For D, you can see that right here, you have a repetition of x values, right? The ordered pair for this lower one is -3 and 2. And the ordered pair for this higher one, also -3 and 4. Again, repeated x values. So this one, not a function, okay? The last thing we're going to take a look at today is set and interval notation to list domain and range, okay? Now remember, set notation always has an x or a y, depending on whether you're talking about domain and range. It always has a vertical line, which means such that. And then you have to say something about which x values are included or which y values are included. So, if we take a look at the x values, since this line goes off the grid, we assume it goes to infinity in this direction and to infinity in that direction, okay? So when it comes to discussing the domain, the lowest value here for your domain is -infinity. The highest value for your domain is right here, right? The furthest it goes along the x-axis is to +3, okay? So your values for x have to be less than or equal to 3, right? They're all to this side or to the less than 3. And greater than, it can never be equal to because it can never actually reach infinity. So we just say greater than, negative infinity. And since we have a solid line, we say that x is an element of the set of real numbers. Now for y, let's go back to x for a second. You'll also sometimes see the domain written without mention made of infinity. So sometimes you'll see it written as x such that x is less than or equal to 3 and x is an element of the set of real numbers. The only difference is we basically just say, well, if I write it like this, it means x can go all the way down to infinity. So either of these is acceptable. Okay? For y, you'll see that since the line goes down all the way to infinity and up all the way to infinity, I could say that y has to be less than infinity and greater than negative infinity. And y is an element of the set of real numbers. Again, because I have a solid line, it's going to be real numbers. But if you think about it, there are no restrictions on y, right? Y could be any number you want, from negative to positive infinity. So a shorter way of writing this is simply y such that y is an element of the set of real numbers. We don't have to talk about restrictions in this case because there are no restrictions on y. It could be any number, okay? So either of these is correct. Your grade 11 math teachers will say, I'd rather you write it this way, okay? Now, what about interval notation? Well, interval notation is so easy once you have these parameters. Your interval notation is going to have exactly the same. You're going to have negative infinity, comma, 3. Because 3 is included, we put a square bracket on this end. Because negative infinity is not included, we put a round bracket on that end. For the range, again, we said it goes from negative infinity to positive infinity. Since they're both untouchable, they're not included, so we use round brackets. Okay? We'll do one more. We'll do one that looks whoa, where are you? There you are. We'll do one, I like this one. We'll do E. Okay? And then we'll be done. So, the reason I want to do E is because you can see right here, E has an open circle, and that means that particular value is not included. Okay? So, when we check our domain, which is the extreme left to the extreme right, our domain, so x values such that our lowest x value, the furthest to the left, is negative 2, but x can't actually equal negative 2. It has to be greater than negative 2. So because we have an open circle here, it means we have to use the greater than sign rather than greater than or equal to. So x has to be greater than negative 2. At this side, the extreme largest x value would be infinity. And again, x can never reach infinity, so it can't be equal to infinity. And we say x is an element of the set of reals because we have a solid line. Now, how would you use interval notation for that? Easy. It's exactly the same. So you have a 2, you have an infinity. Because 2 is not included, we use round brackets. And because infinity is not included, also round brackets. Okay? Now remember, when we're talking about the range, we're talking about the absolute lowest value and the absolute highest. Well, this goes to the edge of the grid, which means it goes on forever. So our maximum y value will be infinity, our minimum y value -3, but again, just as with the domain, it can't equal -3 because you have an open circle. It's almost there, but not quite. So y has to be greater than -3, not greater than or equal to, and the maximum value is infinity, and y is an element of the set of reals. Okay? For our interval notation, same idea, exactly the same values, -3 and infinity. Infinity can never be reached, so we have a round bracket. -3 is not included, so we also have a round bracket. Now, is this a function? Remember, if you have a graphed line, it's easy. Apply the vertical line test. No matter where you drop a vertical line here, it only crosses once. So we say, yes, this is a function. If we take a look at f is not a function because it fails the vertical line test. So we say, no, it's not. It fails. Very quickly, just one more example of domain and range. Remember, your domain is minimum x to maximum x, which in this case would be x such that x is between -3 and 1. So -3 and 1 has to be greater than or equal to -3, less than or equal to 1, because we have a solid line. X is an element of the set of real numbers. For our interval notation, again, once we've got these things, it's exactly the same. Because -3 and +1 can be included, we use square brackets. Now, for the range, instead of looking left and right, we're looking for the top and the bottom, so the absolute maximum and minimum values, which for our range in this case, y such that y has a minimum of 0, a maximum of 4, has to be greater than or equal to 0, less than or equal to 4, and again, an element of the set of reals. Okay? And our interval notation uses the same numbers, 0 and 4. Because we have the or equal to signs, we know they're included and that we can use square brackets. I hope that helped. We'll take a look at function notation, reviewing that tomorrow, and interpreting graphs as well. See you tomorrow.